Hello world, good morning, good afternoon, good evening. Welcome back to codingscientist.com. You are watching Hero to Superhero series on coding artificial neural network from scratch. So guys, I hope you have followed all the previous 3-4 lessons. We have started building our neural network from scratch and I hope you guys are following. In case if you have any doubts, any clarification, do message me. You have my WhatsApp number, you have my cell phone number, you have my email ID, you have my GitHub, everything. You can feel free to reach out. I will be happy to assist you one-on-one. So guys, let's move on. Alright, so let's take a look where have we reached so far. So we started with basically, initializing the network. That was our lesson number 2. So you guys understand this, and then we moved on to neuron activation, right? So you did see how we activate the neuron between the input layer and output layer and the hidden layer. So this is the code all about. Now we need to do the neuron transfer. So it's just about 2 lines of code. Pretty interesting, right? So guys, though it looks like 2 lines of code, so basically it's a pretty complex thing. So those of you from machine learning and deep learning will definitely understand this, but I want to reiterate and re-explain the facts that once a neuron is activated, we need to transfer the activation to see what the neuron output actually looks like, right? So different transfer functions can be used. One of the classic traditional transfer function is sigmoid activation function. It's most popular function, but you can also use the tanh, that is a hyperbolic tangent function, to transfer the outputs right from within the neural network. So more recently, the rectifier transfer function, it's a new type of neuron transfer function called rectifier transfer function, has been picking up in the market. It's been more popular with large deep learning networks. It's widely used across the industry for practical applications. So that's why we got to learn about that as well. The sigmoid activation function looks like the S shape. Basically, once we see the output, I'm going to walk you through that at a later stage. So that's how it looks like. It's also called the logistic function. So you need to understand this, right? It can basically take any input value and produce a number between 0 and 1, that is the binary, right, on a S kind of curve. So that's how it looks like. It is also a function of which we can easily calculate the derivative slope that we will need later on when we back propagate the error. Of course, I'm going to talk about the back propagation and the forward propagation at a later stage, and we are also going to look at the error and adjust the weights accordingly. That's going to be at a later series. So basically in this code, you can see that where E is the base of the natural algorithms, that is the Euler's number basically, and then the function named transfer that implements the sigmoid equation. So now that's the critical piece. So guys, go ahead and pick up this code. It's pretty easy to understand. It's just 2 lines. So this particular line of code basically activates your neuron, and post activation this basically transfers the data from one point to the other point between input to output, crossing the hidden layers. So you will understand this better more than me. I know all of my viewers are experts in this field, and this is just a hand-holding session. So guys, if you have any questions, do reach out to me. I'll be happy to assist you. I will see you soon in the next lesson. Goodbye.